So recall when we were solving for f of x equals x squared plus 4, we found that the roots are 0 plus or minus root negative 16 over 2, which we have right down here. Well, knowing what we know now, we can realize that this is 0 plus or minus 4i over 2, which is 0 plus or minus 2i. Let's connect this with the graph we saw earlier. Okay. So our roots are actually equal to 0 plus or minus 2i. Let's see what would happen if we did look 2 units to the right and 2 units to the left of our quadratic. So let's look at f of negative 2 and f of 2, both of which give us 8. So we could imagine plotting the points 2, 8, and negative 2, 8. Well, what I see is that if I were to reflect my parabola over this red dotted line that I just drew, that this reflection would indeed cross the x-axis 2 units to the right and 2 units to the left of my line of symmetry. So the green points up here are a reflection of imaginary roots that we would get if we were to actually reflect our quadratic function, our parabola, at the line that exists at the vertex. This might be a little tricky to wrap your head around, so we can look at one more if you want to. Let's clear some space at the bottom. Here we have f of x equals negative 2x squared plus 2x minus 5. Using the quadratic equation, I get negative 2 over 2 times negative 2 plus or minus 4 minus 4 times 2 times 5, which will be 40, all over 2 times negative 2, which is a negative 4. So I get a positive 1/2 plus or minus root negative 36 over negative 4. And since we now understand imaginary numbers, we know this is plus or minus 6i over negative 4. So we get 1/2 plus or minus negative 1.5i. Which means if we were to graph this, we still have a line of symmetry at 1/2. So I'm going to use half units on my points here.